Again, we're here. Welcome back now to our channel. Welcome to our discussion. And this time, we will be discussing a linear differential equation. Again, this is another way of solving a differential equation of first order, first degree. Now, when can we say that the dE is linear? So, the dE is linear if we have these conditions. Okay? First, we have to consider the general form of a first order, first degree linear differential equation. So, we write the terms. Now, we consider terms a dy dx term. So, this is a term bearing the order and the degree of your dE. So, you notice that the coefficient of which is a purely x function. The second term is the function y term, no? And its coefficient is also a purely x function. Now, there is also a function that is purely x, which is placed at the right. Now, and this is linear in y, d. Now, for linear in x, so dx dy, then the coefficient of that is purely y function. So, your x is dependent with y. The second term is a term that contains x with a power which is exactly 1. So, we have also a coefficient which is a function that is in y, and function that is purely y is placed at the right end of our equation. Now, out from this arrangement of terms, no, then we can have this be observed to consider our differential equation being a linear dE. The dE is linear in y if it does not contain a term involving a product of a function and y and dy. Because it's not possible to have this when it is linear in y considering this. No? If this is a dy dx term, so there is no chances of having a term expressed as a product of y and dy because this is purely x. So that is the condition where the dE is linear in y. And similar to having a dE that is linear in x if there is no function in x multiplied with a dx, because if this is x and this is purely y, so we cannot really say a term that is expressed as a function in x and a dx. So this is a condition, or these are the condition for the dE to be considered as linear. Okay? Now, the standard form of a first order, first degree linear dE, okay, so we have to arrange the term as this. So, linear in y, you can start with a purely dy dx term plus a term involving y. So, as if imong i-divide og every term, no? Okay, so we have the piece of x, then coefficient niya sa y, then we have a purely x function placed at the right. Now, actually, that is the effect if you divide every term by a. Okay, so I'm going to divide, and they remain to be a function in x. So, linear in x is the arrangement can be dx dy plus x term, and the coefficient is a purely y function, and the right hand member is a purely y function. Now, how to solve? We are given a summary here on how to solve. Okay, so you have to write the dE to follow the standard form of a linear dE, which is this one. And after writing the equation to follow a standard form of a linear dE, we can now proceed with the integrating factor. The integrating factor, so if that's linear in y, it is the exponential of the integral of the piece of x which can be taken out from the standard form, which is kini. Okay, then integrable siya with variable x. Okay, so you can have the if. Now, if the d is linear in x, so ang atong if can be taken also from the same formula, but the function is a function which is in y, and the integration is done with a variable of integration also, which is y. The piece of y is taken from the standard form. That is why it is important to write our equation to follow a standard form. Then you can obtain the general solution, linear in y, so y times the if you solve in step 2, then equal to the integral of the cube of x which is taken from here. Okay? And you multiply that with the if you evaluated in step 2. So, integrate that with a variable x as variable of integration. Then you can add your c because it is a general solution. And that is the same with linear in x. So, x times the if, then the integral equal to the integral of the q sub y taken from the standard form multiplied with the if, then dy plus c. Actually, this is summarize the derivation of this on how we arrive with this kind of if and solution are actually shared in our LMS for those who are under me. No? Sa atong mga bisita dire, so you can just read with the introductory part of the linear differential equation. Okay, so sa mga bisita na to dire, welcome to our channel and try also to invite others to follow with our YouTube channel. Okay? And invite them to subscribe. Share this because this might be helpful also to others. Okay, so continue. Ay, isang commercial, sir. Okay, bitaw. Sige, continue. So, if you are asked to solve the DE, okay, so you are given a DE written in a general form of first order, first degree. Not necessarily be linear, no? But we have to inspect its linearity based on the definition. Ningon man ta ganina, if the DE is linear in y, then it must not contain a term involving x or a function in y with a dy. And it's good because in a dy term, the dy here is associated with a function which is not y. So this is x. So it could be linear in y. Now, ningon ko it could be linear in y because I have to check with the presence of my y if my y here appears with a power which is exactly 1. Because if that's linear, your y must have a power which is 1. And that is true to this. So meaning, this is linear in y. Sometimes the linearity can also be true to x. But if you have to check if this is dx, now, disqualified na nga naman. Doon naman kay x dx form. So it cannot be linear in x. So the only linearity to our differential equation given belongs to the variable y. So it is linear in y. Now, writing our equation to follow with the standard form. So I have to consider my guide now, which is the standard form of linear DE and y. Terms must be arranged starting with a dy dx plus the term involving y or p sub x y equal to the q sub x. So we have to rearrange. So to form the dy dx, so I have to divide with dx and this expression can be used as their divisor. Okay, so there I have the result. Okay, now I am providing x to the fourth power in its denominator and I have to let my dx be the denominator of a dy. As a result, we have dy dx plus the whole expression is divided with a negative of x to the fourth power. Then I have to further rearrange. The next term is a term that contains y, which can be sent out from the second term. Okay, so this can be my second term. And I have to simplify. There is 3, there is x cubed, and there is x to the fourth power. That means it can be x belonging to the denominator side. It becomes plus because both are negative. So this is supposed to be negative, the purely x function. But when it is transposed to the right, then the term now becomes positive. Now, after writing the equation to follow a standard form of a linear DE, then that's the time I can determine what is the piece of x, which is the coefficient of your y. In this case, we have 3 over x. That right? And our q sub x is 1 over x to the fourth power. Okay, ay nalang pangutana sir kay di may katubag. Okay, mutana ra ko para kahuna-huna sa mo gamay, no? Okay, so piece of x, q's of x are there. What is next after writing to standard form and determining the piece of x and the q's of x? The next step there is to solve for the if. And we are given a formula to find the if. What's the formula? The if is the exponential of the integral of the piece of x dx. So we have values out from the standard form. Okay, so we have the exponential of the integral and my piece of x is 3 over x dx. To integrate, I can put my 3 before my integral sign. So, there I have the dx over x, and it's covered with a formula that is equal to the exponential 3 ln y. If there is ln and there is e, so allow your expression to have a coefficient of 1 by taking your 3 as a power to your y. Okay? As a power to your, this is not y, this is x. Okay? But y, this is x. Please make correction. Okay, and that's equal to, nakabalik siya, place correction, correction niya rin, ha? Okay, so the ln of x cubed, and the result in its simplified form is just x cubed. Okay? So after knowing the IF, you can proceed with the general solution. We are also given a formula that y must be multiplied with the IF, and that's equal to the integral of the q sub x times the IF. So we have the dx then plus c for the general solution. Okay, so y with your IF, this one. And we have equal to the integral of 1 over x to the 4th power, x cubed dx. So, before you integrate, so do the simplification. This is dx over x, so that means if you integrate, this is ln x. So, what is your general solution? That would be x cubed y equal to ln x plus c, and this can now be your answer. If there is a condition of the problem to arrive at a particular solution, then that's the time you have to continue considering that one to solve for your C to arrive with a particular solution. But for this case, now there is no condition given, so you can stop up to the general solution. Now, another example. Okay, so we're almost done. Sa inyong ilan yan na si subscribe, no? Okay. So, subscribe sa ginoang, no? Number 2. Okay, so, finding the solution of a DE, which is written as this, or given as this. Can you check the linearity? Could it be linear in y same as ganina? As in number 1, it cannot be. Nga naman, there is a y dy term. And if it's linear in y, there must be no y dy term. Ay nalang pamugos anang y dy ay linear in y, sir. Kay naamay lain nga dunay klaro nga linearity. And that belongs to x. Because if this is dx, then there is no chances of having a function in x dx term. Because the coefficient of this is purely y. So that means this is linear in x. For the power of x, you try to check. Because if that's linear, the exponent of x must only be 1. And this is x containing a power 1. Okay, so what is the standard form of your linear DE? The standard form is dx dy plus p sub yx equal to the q sub x. So that is our guide on how to arrange the term. Okay, dx dy. So dy can be the denominator of dx. And this expression can be a denominator of this entire coefficient. Okay, now let us proceed. So, 4xy squared minus 2 is divided with y plus y cubed. To further arrange, I have to look for a term that is containing a factor x. Which term is that? Kanang dunay x kini. Okay, so this can be my second term. So, meaning, this is my second term, which is 4y squared over, I take a factored form, because this is a fraction, and there may be a possible reduction to Lewis term, so this is your x term. Your purely y term is minus 2 over the y plus y cubed. If that's transpose, no, because you have to separate a purely y function, so it can be arranged as this. Okay? But y squared can be reduced because there is y, factor y in the denominator. So I have 4y, then over 1 plus y squared being your p sub y. The q sub y is 2 over, I may also write that in a factored form. Okay, so that's your q sub y. After writing the DE in a standard form, then we can proceed with a IF. No? Okay, so what's the IF? There's a formula for the IF. Exponential of the integral of the p sub y, and my p sub y, sir. Okay, so it says substituted. So, if my u is, what's my u? Quadratic. Okay, so 1 plus y squared, I know that my du must be 2y dy. That is why, out from 4y, I associate my 2 to together with y being part of the differential. So what is left is only 2, and that is from 4. No? So ang 2 na lang when is gawas because the other 2 is used being a part of the 2 to have the exact differential. So this is now du over u. And that is equal to the exponential of, okay, so 2, and this is the integral of this ratio. So ln of 1 plus y squared. Again, 2 can be used as a power. So that if you have e and ln, so this can be simplified being this as the simplified form. So we have if, which is the quantity 1 plus y squared. Okay, square. Okay, so knowing the if, we can proceed with the general solution. Y, so man, y or x? Linear in x man, so it is x times the if equal to the integral of the cos of y times the if dy plus c. Okay, so this is the formula, and we substitute what we obtain, the if, x being linear in x, and that's equal to the cos of y. Where is your cos of y? This one. Okay, so that is 2 over 1 plus y squared, and then we have, what's naman is ya? Cos of y. So the variable of integration is y. So we can simplify. We can reduce this. No? So this is out, but there is still 1 plus y squared that is left. Constant factor 2 is placed before the integral sign. Okay, now, the only divisor left is y. And this is an improper fraction, no? So, I have to divide each term 1 over y plus, what's the last term? Y. So, we have different formula applicable. This is 2 ln y for the first term. This is supposed to be y squared over 2, but when 2 is distributed, then we can arrive with y squared for the second term, then plus c. Okay? So, this is now your answer, and that is the end of our linear DE. Okay, so thank you for being with me. So, thank you for watching. And I'm happy to share this to you. So I hope you will also be happy to share this to others. Okay? Bye-bye and good day.